Hello and welcome to yet another video. I am Shomik and I humbly apologize to everyone because yesterday I was not able to come up with a video. Yesterday I had some system issues and my audio driver was probably corrupted or somewhat. Anyway, so this question is termed as unique paths, and again it's a pretty famous question. This was the question that I was I was being asked in my Google internship period, when I was sitting for the Google internship entrance, or I would say the Google internship tests. So yeah, so this is a pretty interesting problem, and let's get on with the problem. And also comment down below whether I did justify the logic, and many people explain this problem in not a very good way, which is not understandable, though the problem is quite simple, but then also it's there in the medium tag of Leetcode, and generally all the medium tags are very good problems and you should definitely look out for them. You should definitely practice them. Okay. So here we go. A robot is located at the top left corner of an m into n grid, which is marked as start, correct, in the diagram below here. The robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corner of the grid, which is marked as finish. How many possible unique paths are there? So some sample inputs and outputs. So basically if m equals to 3, n equals to 2, then output would be 3. We would get into that later. So how do the robot actually goes down? The question is, I start from the top left and I need to go to the bottom right, and meanwhile I can travel only in right and in down direction. I cannot travel in up and left direction. So let's get on to the explanation. So let's say I need to go to the finish. So one way that I can move is I go here, then I go here, here, and then finally in finish. So this is one way. Other way could be this: I go straight here, then straight here. Another way could be as simple as this, then coming over here, then coming over here. So these are 3 unique paths. So there are multiple unique paths. So how many unique paths I can reach to start to finish? Now before we actually look at, these were the valid paths, okay, so before we actually go and code this, let's look at some invalid paths which cannot be taken, because remember, I need to move only up, I need to move only down and right, correct? So any move that which I am not moving down or right is not feasible, right? That path is not feasible. So if I have a path of this sort, let's say I go here, then I go here, then I go here, then here, then here, this is a total invalid path. Why this is a total invalid path? Because at this particular point I am moving from, I'm moving towards my left, which is not not viable. This move should not be there. I should only move either to right or either to down, correct? So this is one invalid path. Similarly, let's say from here I move over here, then I move here, then I move here, then I move here. This is also an invalid path, because what I do is I basically move upwards here, which is also invalid. I cannot move up, right? Here I am moving upward, correct? I am moving from a cell of 4 comma 1 to I am moving 4 comma 0. So sorry, 1 comma 4 to 0 comma 4, which is not true, which is not viable because I am moving up. So these are the invalid cases. Also, another thing that you need to keep in mind is you cannot move diagonally. So this, if you move here, then from here you move here, So this is also an invalid path, because you are not allowed to move diagonally. You can only move in the adjacent right cell or the adjacent down cell, right, the below cell. So these are some of the things. Now let's look at how we're gonna approach the problem. Now first let's find some cases. So what happens if I am given the finish to be here? Okay, let's say I need to go here, the black dot. Okay, so in how many ways I can go there? So let's see. Can I just go here, then go down, go here and go here? No, because I cannot move upward. So this particular step that I've done right over here, this is wrong. So can I just go here, then here, then here? No, again I'm moving upward, it's not true. So maybe can I go here, then maybe here, then here, then here? So this is also a wrong step, because I'm also moving left, which is wrong, and I'm also moving up, which is wrong. I cannot do that. That's not a viable move. So the only way, if we see, so the only way to reach such a point is if we follow a straight line path from the start to the point. Why? Because it's pretty clear that if at any point of time I am in any of my cells, in the row 1 or in the row 2, then it's impossible me for go to row 0, because I cannot move upward. So for any cell that is in the row 0, I need to keep my robot on the row 0 only. I should not go downwards. Correct? If at any stage I go downward, I won't be able to come up again, so I won't be able to reach that point again ever, right? So basically, so every point that is in the 0th row would be visited in only one unique way. Only in one unique way they all can be visited. Correct? So this is one thing that you need to keep in mind also. Now the question is, what happens if I want to visit a point, let's say, which is not over here, but it's here, it's somewhere here, or let's say not exactly here, okay, in the 0th column. What happens if I want to visit any point in the 0th column? Let's see. So let's jot out my valid paths. So is it a valid path? No, because I went down, that's okay, but at this point when I'm here, I cannot move left. Left movement is not allowed. I can only move right, or I can only move down. Correct? Okay, so this is an invalid path. So if we see again, similarly, the only viable path to reach any point on the 0th column would be a straight line from the start. Correct? So to conclude, I can tell that I can visit any point, whatever the point be, in the 0th column and the 0th row in only one way, and that's just go from the start and keep on visiting them in a straight line manner, in a straight fashion manner. Correct? So if I tell you, let's say I write the number of ways in which each cell can be visited, so these all cells that I am marking can be visited in only one way. Correct? So let me mark all of them first. They can only be visited in one way. Now, in how many ways can this cell be visited? In how many ways can this cell be visited? This particular cell. So let's see the path. I can come to this cell, this particular cell 1, 1 from either from the up or the left, because if the robot is here, then it may go first, it may so it may first go here, then come here, or it may go to here, then come here. So there are only two paths, there are no more paths left, correct, to visit this point. So the number of ways to visit this point is 2, and how are we getting that 2? So I can, now this is the thing, that's the main thing that that you should be wondering upon. If at any point, at any square, I can either come from its left square, or I can either come from its up square. Because if I am here at time t, then at time t minus 1 I could either be here or here, correct. So in how many ways I can traverse this square, and in how many ways I can traverse this square, the addition of both the ways would give me the total number of ways in how many in how many ways I can traverse this particular square of interest. So basically, if I sum that up, so if I need to, I'll at finish. Okay, I'm at finish. So how did I come to finish? I either came from this, or I either came from this. Now how do I came here? I either came from here, or I either came from here. Again, how do I come here at this point? I either came from here, or either came from here. So if you see, this is a recursion problem. So for every cell, this finish would ask me, hey man, in how many ways you can reach me. Is to know that, you need to know in how many ways you reach my above cell, and in how many ways you reach my left cell. So the program doesn't know in how many ways you reach the above cell, or in how many ways you reach the left cell. Now the program will call again itself, for now it will call for the above cell. Now it will ask me, hey above cell, in how many ways people can traverse you. The above cell will say, I don't know yet, let's consider my above cell and my left cell. So again, this function, this and this will be called. So that's a classic recursion problem. One thing that you might be seeing is, for this particular cell, okay, for this particular cell I am calling this and I am calling this, right? So for finish I am calling both the cells. Now for this cell that is just above the finish, I am calling my left cell, I want to see, and I also want to see in how many ways I can traverse my upward cell. For this particular cell, again in my left cell of the finish, I am calling my above cell, but then it has already been called once. Do I need to call it again? So there are overlapping calls. So once there are overlapping calls, it's a DP problem, right? DP is nothing but recursion with storage. So when I call something, I need to store that so that I don't call it again. So I hope the problem is pretty clear. So basically, for every cell I comma j, I would call my I minus 1 and j minus I minus 1 comma j and I comma j minus 1, which is I comma j minus 1 is this, and I minus 1 j is this. So I'll call both of them and I'll add the value, and that would give me the number of ways I can visit this particular cell. So I hope the explanation was clear. So just for the understanding, first I'll go with the recursion approach, and then I'll show you how the time limit is getting exceeded, as a result of which I cannot we will move to DP. So maybe let's name it n paths. I'll have int m comma int n. So m and n are nothing but the values. So in this example, m was 3 and n was 7. So basically I won't be passing m and n, rather I would be passing m minus 1 comma n minus 1, correct. So for this particular cell, I would be passing m minus 1 and n minus 1. So basically I'll pass int answer is equal to n paths. Okay, I'll have m minus 1 and n minus 1. Now I'll just return my answer, and that should do. So if my m is equals to 0 or n is equals to 0, remember the base case where the column where my point lies in any column. So basically, if my point lies in the first row, so the coordinate m comma n, the m would be 0, correct. If my point lies on the first column, then the coordinate m comma n would be 0. So if any m or any n, or if both of them are 0, so basically that is an OR condition. If m equals to 0 or n equals to 0, I would straight away go and return 1. Please return 1, right? Else what happens, I'll return what? I'll return in how many ways I can traverse this particular m comma n, correct? So in how many ways I can traverse this particular m comma n? I can traverse this particular m comma n in number of ways that I can traverse this, the above cell, plus in number of ways I can traverse this, the left cell. So at any point m comma n, the above cell would be what? The above cell would be m minus 1 comma n, correct? And the left cell would be m comma n minus 1, correct? So I need to find in how many ways they can be traversed. So this is exactly what my function does, in how many ways m comma n can be traversed, correct? N paths does that. So I'll call n paths for these 2 points as well, and it, as you can see, it takes the form of a recursion, m comma n minus 1, and that's it. So let's run our code first. Okay, so some few test cases, it's giving the correct answer. Let's test with the random test cases. 6 comma 4, 56, it's giving the answer. Let's test with maybe 3 comma 7, the example that we took, right? So let's run the code, and it's giving me 28, which is accepted. That means the correct answer. But if I submit this code, so one thing that you will see is there's a time limit exceeded error. So basically the time limit exceeds because for each recursive call I am calling my function for 2 to the power n times in total. So I don't need to do that. So I'll maintain a dp. So I'll make dp n plus 1 and m plus 1. So for every m equals 0, correct, and n equals 0, I would set my value as 0. So I'll set my dp of I, or rather I should say I comma 0. So every column, every column, 0th column I would set 0, and every cell in the row also I would set 0. So in the row n would vary, j would vary. So dp of 0, any column on the, any point on the 0th row is 1. Okay, now basically for int I equals to 1, so basically what I have done is I have filled up all this. I have filled up this with 1 and 1. Okay, so I have filled up this and this with 1 and 1. So for every column, so I'll start with every cell, that is 1 comma 1, correct? So I'll start with the cell 1 comma 1. So in how many ways 1 comma 1 can be reached? It can be reached in 2 ways. So the addition of 0 comma 1 and the addition of 1 comma 0. So basically left cell and up cell. So for every let's run the loop for every cell starting from 1 comma 1. So it would be this. For every cell again here I would have my dp of I comma j, right? Dp of I comma j is nothing but the value, the number of ways the ith cell and jth column can be traversed, I comma j column can be traversed. So this is nothing but I and j minus 1. I hope it's clear. So I don't need all this stuff. So at the end I would be filling my table, and my whole table would be filled up until here. So at the end my answer would be at this cell, correct? So this is what cell? This cell that I am marking. So I think the marking was not pretty much clear. Okay, so this cell is what I am looking for. At this cell my answer would be what? I need to return whatever the value of dp at 2 comma 6, but since I have taken one extra space, I have taken plus 1, so I'll just go out and return dp of m comma n, and that would do. Let's see, let's run the answer, run the code. Okay, so since I have taken one extra element, I can pass m comma n directly. So you could have not passed also, you could have passed also, not a problem. What's the issue? Okay, yeah, okay, no, I would be passing this, right, correct. Yeah, I hope it's clear. So let's see if this gives me a TLE or not. I don't think this would give me a time limit exceed now. So no, it doesn't give me. Let's submit the code and this should work. Yeah, so the runtime is 0 ms, which is faster than 100% of all the C++ submissions, and that's pretty good. That's pretty good to see. And that's all. Just leave a comment down below if I was able to explain this DP problem very well, because this is a very important problem. And stay tuned for more videos, and please subscribe. I do regular videos just for you people. Please subscribe. Thanks.